Hello students, today I will discuss about resolution in first order logic. Resolution is a theorem proving technique, that is the proofs by contradictions. Resolution is used if there are various statements are given and we need to prove a conclusion of those statements. As we know that in artificial intelligence we want to perform decision making or reasoning from the machine, and what we are doing, we are initially storing some statements in the knowledge base, and from those statements we want to conclude something. That means if I want to derive some conclusion from those statements, then I have to use the resolution. Resolution has 4 steps. First is the conversion of facts into first order logic. Second is converting the statements which are written in first order logic to CNF, that is the conjunctive normal form. Then whatever we want to prove, we are negating that statements, which is called as proof by contradictions. And finally we are drawing a resolution graph. Here is an example, and it has 5 statements. First is John likes all kind of food. Second is apple and vegetables are food. Third is anything anyone eats and not killed is food. Anil eats peanuts and is still alive. Harry eats everything that Anil eats. So we are assuming that we have stored these 5 statements in the knowledge base. Now from these 5 statements we have to prove that John likes peanuts, and it could be proved through the use of resolution. So as we know that the first step is to, whatever the sentences given to us, we are converting those sentences into first order logic. So John likes, first sentence is John likes all kind of food. So here we have to use the universal quantifier. For all x, food x tends to likes John comma x. Second is apple and vegetables are food. So it can be written as, there is a class which is called as food, and this class is having object apple and vegetable. So it could be written as food apple and food vegetables. Now third statement, anything anyone eats and not killed is food. It could be written as for all x, for all y, such that eat x comma y and not killed x tends to food y. Then the next statement is Anil eats peanuts and is still alive. It could be written as eats Anil comma peanuts and alive Anil. Then the next is Harry eats everything that Anil eats. It could be written as for all x, such that eats Anil comma x tends to eats Harry comma x. Now in this problem we are adding some more predicates, we are adding some more statements, and whatever the statements you are adding, they should be the valid statements. You can add a number of statements. The problem is that while going through these statements, there is no relation between alive and killed. We know that alive means not killed, but for a machine to understand alive means not killed, we have to add the sentences in the machine. So here we are adding 2 sentences. For all x, not killed x tends to alive x. That means not killed means alive and alive means not killed. Now the last statement is John likes peanuts. This is the statement that we have to prove. So we are also converting this statement into first order logic, which could be written as likes John comma peanuts. Now the next step is the statements written in first order logic, they are converted into CNF. CNF is the conjunctive normal form. So here we are having some rules through which we could able to convert these statements into CNF, and here you could see that we have to remove the sign of implication. So if alpha implies beta, it could be replaced as negation alpha or beta. So by applying this rule, we are converting all these statements. We are removing implication sign from all these statements. Now in the next what we are doing again in converting into CNF, what we are doing, the negation sign, which is the negation sign, we are moving inward. That means if for example, if the bracket, we have to solve the bracket by using this sign. For example, in the last statement you could see that here you could see that negation is outside the bracket, so we have to move the negation sign inside the bracket. And whenever you are moving the negation sign inside the bracket, then the logical AND becomes logical OR. Okay, logical OR becomes logical AND, reverse happens, and negation happens. If for example, if there is negation X, it becomes X. So we are applying this rule. Then in the next step, what we are doing, we are renaming variables. For example, here there is a variable X. For the moving, again I found that there is one more variable which is X. So all the variables should have a unique name. That means X could not be repeated. If already there is an X, you could not repeat X. So what I am doing, I am renaming all the variables. So I am having only in a single statement I am having X, then another statement is having Y, Z, and so on. Then the removal of existential quantifier in this statement. In these statements we are not having any kind of existential quantifier, so there is no use of this statement. And finally what we are doing, we are dropping all the universal quantifier. That means for all X, for all Y, for all Z, all these statements should be removed. All these part of the statement should be removed. Now in the here we could see that the statements which are having logical AND, for example, food apple and food vegetable, these statements can be broken into two statements. That means the statements which are having logical AND connective, these statements could be written as a separate statements. So the number of statement increases. And distribute conjunction and over disjunction, so we are not having any statement which are written in this form, so there is no need to apply this formula. So all these steps what we have discussed, they are the part of conjunctive normal form. Now this statement we have to prove. So in the third step what we are doing, we are negating this statement, John likes peanuts. So the negation of this statement is John does not like peanuts. That means negation likes John comma peanuts. Now in the last step what we are doing, we are drawing the resolution graph. So we are starting from the statement which we have written in the third step. That means negation likes John comma peanuts. We are starting from the statements, and what we are doing, we are searching all these statements. We are searching all these statements where we could able to find a statement which has the predicate likes, because whenever you are writing any statements which are having a predicate likes, then not likes and likes cancels itself. So here I am writing the first statement, and after writing the first statement, likes and not likes and likes cancels itself. So what is remaining? Remaining is food X, but here we are writing it as food peanuts, because whenever you compare these two statements, okay, whenever you are removing likes John comma peanuts and likes John comma x, you could able to see that the variable x has value peanuts. So here we are applying the process of unification, which is also called as substitution, and the variable x has been replaced with the peanuts. So the remaining statement is not food, or bracket mein, in bracket we are writing it as peanuts. Now again we are searching for the statements in which we are having a predicate food. So you were able to see this, the fourth statement, that is the not eats y comma z, or killed y or food z. This statement is having food. So food and food cancels. So what is the value of z? Z is the peanut. In this we are drawing the resolution graph, and finally we are getting an empty statement. Empty statement shows that it has been proved. Hence the negation of the conclusion has been proved as a complete contradiction with the given set of statements. So this is all about the explanation of the resolution graph. Thank you.